Certainly you gotta have it. So anyways, establish identity, cosecant theta minus cotangent theta is sine of theta over 1 plus cosine theta. You do have choices. You can work with the left or the right, but generally speaking, the goal is to make the left-hand side look like the right-hand side. So that's where you should start. That's your goal. Make the left hand look like the right hand. And Jaden, don't try to do something to both sides. I didn't. I know what you were trying to yesterday. So we have cosecant minus cotangent. What would you like to do with cosecant?
1 over sine.
1 over sine's not a bad idea. Not a bad idea at all.
And then you do cosine over sine?
Cotangent is
Cosine over sine.
cosine over sine. You know what you should do next?
No, that was as far as I could get.
Do they share the denominator?
They stay the same denominator.
It's 1 minus cosine.
If somebody asked you what 1/4 minus 2/4 is, would you hesitate?
Yeah.
Would you hesitate if somebody asked you what 1/4 take away 2/4 was? No, you'd say -1/4, wouldn't you? That's the same thing, isn't it? The denominator's common. 1 minus cosine of theta over what?
Sine of theta.
Getting close. Actually, very close. Your goal is to become sine of theta over 1 plus cosine theta.
Is it not a reciprocal?
Is the top sine? No, it is not. Not yet.
Why isn't that a reciprocal?
Huh?
Why isn't that a reciprocal?
Huh?
Never mind.
I was actually going to mention the reciprocal.
Why? It is a reciprocal?
It is the reciprocal of 1 plus cosine
That's
theta.
what I'm saying. The reciprocal.
Sorry, conjugate.
Conjugate, yes. Sorry.
It is conjugate of 1 plus cosine
I'm
theta.
always going to mess that word up.
Normally, when you worry about conjugates, you multiply, you just try to clear the bottom, right? Like if the bottom was 1 minus cosine theta, you might multiply both pieces by 1 plus. The reverse works often too. What's the conjugate of 1 minus cosine theta?
1 plus cosine theta.
When you see funny looking things like that, it doesn't matter if it's numerator or denominator, use conjugates. I taught calculus, I think a couple times we had to do this before we'd actually take a derivative of something. We had to clear it, make it look different. Boil up top, distribute down low. And actually, when it comes to the bottom, I think I'd leave the bottom factored. I don't think I would actually distribute the bottom. So what you get if you FOIL out 1 minus cosine theta times 1 plus cosine theta?
1 minus cosine squared.
1 minus cosine squared. I'm glad you see that. You need to be thinking about sine squared plus cosine squared is 1. That's something that needs to be on your mind.
If I'm ever going to be able to do these, I'm going to have a list of all this stuff.
And I guess whenever you take a test, you better write it all down. Because I'm not even going to do it.
Obviously.
I can't.
I'll be clever.
Anyways, shift your cosine squared over. You'll be sitting at sine squared theta over sine of theta times 1 plus cosine theta. I know we did this yesterday. What's sine squared over sine? Sine over 1. So we end up with sine of theta sitting over 1 plus cosine theta because those guys cancel out. That was your goal. So what you learn from that one is be thinking about when you can use the conjugate property. Right? That's something you just stick around. It's just a technique. If you think you can multiply by a conjugate, try it. It might get you somewhere. And eventually you'll feel pretty good. Anybody watch Lord of the Rings? Well, that would make a lot more sense if you had. Never mind.
I mean, it's
Establish identity. Sine squared of theta minus tangent theta over cosine squared of theta minus cotangent theta is tangent squared of theta.
Tangent, sine, cosine.
No.
Can't do that.
Are they common factors?
I just said the tangent, sine, cosine.
Are you wanting to rewrite this as sine over cosine?
Maybe.
Oh, I thought you were looking at this.
Uh-uh.
Yeah. That's not a horrible move.
Throwing out ideas and cosine, sine.
It's not a horrible move. It's worth trying.
Oh, that was fun.
We can teach you how to add and subtract fractions. It's what feels great. That's what I see. I see a pair of fractions in a numerator and a pair of fractions in a denominator. Put them together. What's sine squared minus sine over cosine?
Sine over 1 minus cosine.
minus sine.
Her?
So would that be
Sine over 1 minus cosine.
No.
sine
Wait,
squared
you
of
gotta
cosine minus
cross
sine?
one.
It's kind of cross multiplication. I don't call it cross multiplication.
Oh, you do the AB, BD,
Put that over a 1. What do you give sine squared?
cosine.
Cosine. Minus because there's a minus. Have you give sine anything?
Sine. It's just sine.
Both pieces over? Cosine. You work on the bottom now. What's cosine squared theta minus cosine theta over sine theta?
Cosine, sine, theta.
Cosine squared sine theta.
Cosine squared, sine. Minus
Minus.
cosine, theta over sine theta. Do you cancel stuff? No.
There is some stuff you can do here, but you may not see it till you follow the old rule of how do you actually divide by a fraction. Multiply by their circle. So we'll leave sine squared theta cosine theta minus sine theta over cosine theta alone. And we'll flip that guy. Got my theta. Double line. Too slow. What was that? There's where I was. Anybody see anything?
Can you cancel out those cosines?
What's that, Keely? Sine over cosine. Well, there's multiplications in one here, so this is basically one fraction. It is sine over cosine, which is
Tangent.
tangent. Getting close. So we have tangent times something. Let's look at what we got here. You got sine squared cosine theta minus sine theta. That's two pieces. What do they both contain?
Wait, why are we cross multiplying?
I'm not cross multiplying.
Oh, you're still doing
I was just highlighting it for you. No cross multiplication. You literally have a sine over cosine, don't you? After that, what do both pieces possess? Pull it. Pull a sine of theta from sine squared cosine theta, what's left? Sine theta cosine theta minus 1. Do the same thing at the bottom, except this time pull cosine. Pull cosine theta from cosine squared sine theta, what do you have? You pull cosine from cosine squared, what's left?
Cosine theta, cosine theta minus 1.
Cosine
sine.
theta sine theta.
Sine.
Huh. Are those common factors of the numerator and denominator?
Oh, they cancel.
Yeah, they cancel. Other than orders, it's the same thing.
And sine over.
Cosine is, and hopefully you're looking right here. So you're left with tangent times tangent, which is squared. Wasn't too bad, was it? Of course, when you start doing it on your own, that seems like fudge. Right now, you're doing group thought. I can at least tell you if it's the right move or wrong move. And the truth is, you can usually do these things 2 or 3 different ways. All right, another one. This one ought to be easy. I don't know that I want to waste time on it, but it ought to be easy. What do you want to multiply the left-hand side by? There you go. You saw something, you take the conjugate of, do it. It's a good technique. If you think you can use a conjugate, use a conjugate. And I wouldn't actually distribute cosine in. You catch on the last one I left it factored? Most of the time, that's what you do. Just leave it factored. I hope you caught on here. When you use the conjugate technique, you don't actually do the full FOIL, do you? When you use a conjugate technique, all you care about is having no first and last. That's it. Because what happens to the outer and the inner? They cancel out. Anytime you use a conjugate idea, the outer and inner don't matter. All that really matters is this piece and this piece. So, what do you get? 1 minus sine squared. 1 minus sine squared. So, give Cora a second to figure out what that is.
Right.
It is. Every year there's always a kid who struggles with that idea. When they see these square things, these 1 minuses, they always struggle with that idea. You just go look at your Pythagorean identities. That's all you do. Go look at them. Nothing more. Don't be that kid. It'll happen. Somebody in there will be that kid. Probably Taylor or Zach, because Taylor's not here. We know it won't be Kyle, right? It won't be Kyle. And you're done, basically. Cosine over cosine squared. And there you go. That does it. Wish you're all.
What cancels? Oh.
Wait, if that one's gone, that's no longer 2. That was done. Is there anything actually hard in here?
Okay.
That one's interesting. I actually have no idea how to make the left-hand side look like the right-hand side on that one.
So we make the right.
Or do I? Do I want to waste your time on an idea? That's the worst part. I don't waste your time on an
Let's do
idea.
it.
Sure, we only got like,
The goal is to make the left-hand side look like the right-hand side, not the other way around. The goal is always to work with the left, not the other way around. Cotangent squared would be what? Sine, cosine squared over sine squared.
Where's that?
What's sine squared?
One minus cosine squared.
Mm-hmm. Factor 1 minus cosine squared. Again, I do feel like I might be wasting time. I've never actually tried to do this one from the left-hand side. So 1 minus sine, 1 plus sine. Isn't it? If you don't know that, just look at the previous example. Look at the previous example. I'm pretty sure we did 1 minus sine times 1 plus sine, right? And we had it with 1 minus cosine squared. Yay, nay?
Because 1 minus sine squared is cos.
No, sorry, it's not sine, it's cosine.
Okay.
I was thinking something else. How does that help me? About as far as I had it played out in my head.
What would
Why
happen
do
if
you
you did? Why do you have sine?
I don't know. I was trying to think of the next step. What was reading? I told you my hands don't always keep up with my head.
What would happen if instead on cotangent squared, you did 1 minus cosecant squared? Would that do anything?
That's a pretty good idea too. It's a very good idea.
Also, why do you do 1 minus cosecant squared instead of cosecant minus 1 squared? Or cosecant squared minus 1?
You have to go back and look how we derived it.
Okay. I'm just gonna trust it because I don't want to do that again.
Let's go back to Cora's idea. Cora's idea was to make that 1 minus cosecant squared of theta. Hmm?
Start with X.
Hmm?
I don't know, Jaden, I just got this far.
It's actually almost done. Rewrite cosecant.
Wait. 1 over sine? 1 over sine squared?
1 minus 1 over sine squared theta. Put the fractions together.
What do you mean?
Put the fractions together.
Oh.
What's this one again?
Sine squared.
What's that one again?
1 minus 1.
It's all over sine squared. I thought it was almost done. It might not be as far as I thought it would be. All right, what can we do with this bad boy? Yeah, see, this is why I've never actually tried to do the left-hand side of this one. I've never tried to do it. I know it's like something that's really easy once you see it. I can see it up here. I'm still learning how to work this one backwards. I've never actually tried to work the left one out. Maybe I'll get lucky next year. I don't want to waste any more time on it, kids. I've never tried to work that left-hand side out.
Okay, I have one question.
Yeah.
If, I mean, you kind of, well, what if you did cosecant squared and a -1 instead of the other way around?
I honestly just took it what y'all gave me was true. Is the identity 1 minus cosecant squared for cotangent? My brain's
It's 1 plus cotangent is cosecant.
Oh.
So it is backwards, yeah.
I honestly just took what I was told to be true.
Because I thought,
So that means that cotangent is cosecant squared minus 1. We're gonna blame Cora.
huh?
We're gonna blame you.
Blame me, you told me it was derived the other way.
I just assumed what you told me was right. I didn't even think about it wrong. Usually when I do these, I don't remember the other two. I just derive them as I need them.
I thought it couldn't be cotangent -1. I thought they all had to be 1
All right, we'll give this thing one last shot. Take away the 1. Cosecant squared theta minus 1. Give it one last shot. I would still be very tempted to rewrite that as 1 over sine squared. Do the same thing we just did. Becomes 1 minus sine squared of theta, sitting over sine squared. Conjugate's not a horrible idea. It's not.
Or no, it's just
It would become something interesting. It's not a bad idea. But the thing is, we're doing 1 minus sine squared.
that's just.
It's 1 minus sine squared, that's cosine squared, isn't it?
Mm-hmm.
See, that gets us to what? Tangent? Or sorry, cotangent squared?
Yeah, right to the beginning.
Yeah, it gets you right back to the beginning. It has an issue somewhere. I think what you're supposed to do this one working with the entire left-hand side, is maybe rewrite this as something like sine theta over sine cubed theta. I think if you did that, you could possibly get to the right-hand side. You're supposed to think of an equivalent. Is sine of theta over sine cubed of theta the same as 1 over sine squared? I really think this is one of those you have to go outside the box on to actually get you working the left-hand side. That's why I've never done it. I always had a hunch this was something that was out there. It's brilliant when you see it. Like, I didn't know I could do such a move in mathematics. Yes, you can. As long as it's equivalent, it's valid. But I really think with this one that you have to do something like this. Rewrite 1 over sine squared as sine theta over sine cubed. Again, there's a reason I've never actually tried to do this one, because that's what I always thought you had to do. And I don't really care to show you that you can just kind of make stuff up sometimes, because that's kind of dangerous. So, anyways, on this particular one, I would say make the right look like the left. But do be aware that you can do stuff like that in math. You can literally make something that's equivalent and use it instead. All right, cosecant theta minus sine theta over sine theta. That one shouldn't be too bad. How do you rewrite cosecant? 1 over sine. Actually, I'll tell you what, before we do anything, let's break the fraction apart. That might actually be easier. Just break it apart. What is cosecant theta minus sine of theta over sine of theta written as 2 distinct fractions? It's
Minus sine over,
cosecant theta over sine
you get minus sine over sine,
minus sine over sine.
which is just 1.
Agree with that? How about cosecant over sine?
No, cotangent. Correct.
Good.
1 over sine squared.
Oh, that's cosine.
It's 1 over sine over sine.
One over sine, how?
Cosecant's 1 over sine, isn't it?
Oh.
You're sitting over
Yeah,
sine.
1 over sine squared.
It's just 1 over sine squared. That might have been a bad move too. I don't know.
It isn't.
Huh?
I don't think it is.
You think it is or you think it isn't?
I don't think it is.
Isn't that where we were just a minute ago?
Yeah, I think I got sine over sine cubed of theta.
Are you working on my little idea from earlier?
No, I'm just working from what I saw in there.
I think that that is a bad move, because I think we've been there before.
Yeah, we're just there.
So I think that's a bad move. Anything else you want to try? I just feel like that's a dead end.
I think he must have the top angle by sine theta, and then somehow that would.
Wait, that's cotangent squared, isn't it?
1 over sine squared is cotangent squared?
Minus 1.
Oh, sure is. Yeah.
What?
Those stupid
Okay,
guys.
wait, slow that down for me, what was it?
This is cosecant squared. 1 over sine squared is cosecant squared. And if you go back and you look at identities, and I'll be honest, I'm having one of those
Is that
days.
Pythagorean?
It's Pythagorean.
1 over,
Cotangent squared of theta plus 1 is cosecant squared, right? Is that the identity? I'm having a day. So, if you subtract the 1, you're at cotangent squared of theta. Yep, it was that simple. So we might have actually been there earlier. I don't know. There she is.
we definitely were.
Yeah, we
Yeah,
were.
look what you had to do just to.
Well, I forgot something.
Okay, I'm still having this.
And Cora's not wrong. I mean, if you try to do this all out of your head, you're gonna forget them. On a test day, I'd write those things down. She's not wrong.
All you had to do was.
Yeah, it was pretty simple.
1 over sine squared.
These things will make you feel
Cotangent
stupid.
squared?
Well, you can go ask anybody that's my age, because we never had any of this in high school. Their hardest class in college was trigonometry. You can go ask anybody my age, because we never saw any of this stuff. The hardest class they ever took was trig. You guys have had the fortune of seeing some of it in Algebra 2 and in pre-calc. So, not as bad for you.
I think I need to see that derived, because I'm confused. How
Yeah,
he got
that
the cotangent squared, I can't figure out what I'm doing here.
All right. Yeah, you were a little behind that day, yesterday.
No, I'm talking about what Tatum just said. Is that what you're doing?
Yeah.
How 1 over sine squared or whatever you did?
Sine squared plus cosine squared is 1. Oh, you mean, where did 1 over sine squared?
Yeah.
Well, that's cosecant squared.
I guess I just can't find where I've written that down.
Somewhere you wrote cosecant as 1 over sine.
Cosecant is 1 over sine. Okay, so 1 over sine squared. Okay, that makes sense.
Is that all you needed?
And then cosecant squared is 1 over. Okay, yes.
Okay.
Yes. Okay.
But this little thing is very true. Little SpongeBob meme there. You gotta use your imagination. Good. All right, so I feel a little dumber now. That's normal.
It's kind of fun. I feel like we all work for the FBI. or something. You know, we're just like close over here.
All right, what would y'all like to do?
Or cosine into 1 over sine.
Cosecant is 1 over sine. This one will actually be pretty short. It's almost done.
Sine, 1 over sine cubed. and sign squared.
All right,
Okay, Brody's done. He understands this.
And then you finish
now you look at your back of the entities.
Yeah.
Well, it is 1 minus sine squared. Cosine.
That's that thing, I thought stupid, we passed 4 of them, and now it's finally clicked.
It has to happen. Don't worry, you'll feel stupid again. You will. It's okay.
Yeah.
It's okay. I think, is there one more, or is that it?
Where
Okay.
does sound square come from? Because one of our signs just.
We had, if you look at it, not necessarily the way I wrote it, but if you look at it as sine cubed over sine, the way you probably think about it in your head, because that's what
Okay.
you're accustomed to
That makes
seeing.
sense.
You know, what you see on the board is not necessarily how you do it up here.